Okay, so it's 8 p.m. In Berlin time, and in San Francisco it should be 1:11 in the morning. And so let's get started. And so hello everybody, this is Han, I'm the founder and CEO of Gina AI, and welcome to join this webinar. This is my first time to give such a live stream, and I hope you really enjoy this episode. So today I'm going to give you a very gentle introduction about our recent release open source product, which is called Gina. As you can see here, Gina is the cloud-native neural search solution. And so for most of people who don't know about neural search, so this could be a very good introduction to tell you that what Gina can do and what the neural search, what the future of the neural search could be, right? And yeah, so let's get started. So a few words about myself. I'm the founder and CEO of Gina AI, and before that I worked as an engineering lead at Tencent AI Lab in Shenzhen. And at Tencent I was like leading a team working on the search infrastructure for a Chinese app called WeChat. Probably some of you know that. And before that I was in Berlin. I worked at Zalando as a senior research scientist there, and for 3.5 years. So I got my PhD in TU Munich, in Technical University of Munich, in machine learning, right? So I also studied master's there at TU Munich. Besides all those professional jobs, I also work in a couple of non-profit organizations. That includes I served as a board member in the Linux Foundation of Artificial Intelligence in 2019. And I'm also the founder of GCAI, this German-Chinese Association of Artificial Intelligence, which is an NPO registered in Germany. So I have my personal blog, which is like a tech blog, and you can contact me via LinkedIn or email. So I believe most of you may, so if you work in NLP or you work in computer vision, so you may heard or use this open source project. Right? So one is Bird as Service, and one is Fashion and Needs. So I'm actually the creator of this both open source project. And yeah, so these two open source projects, as you can see on GitHub, they are pretty popular back in the days. Fashion and Needs was released in 2017, where I still work at Zalando. And it quickly now becomes one of the, let's say, the benchmark, the standard benchmark data set for machine learning. And especially for machine learning beginners. If you go to TensorFlow website, you see that the first tutorial, right, of deep learning is using Fashion and Needs. And the other is Bird as Service, which is like a network wrapper around the Google BERT model. And this also becomes very popular. A lot of small companies, startup, and even big companies, they adapt this kind of BAS, Bird as Service solution into their into the production. Right. Okay, so a few words about Gina as a company. We are a neural search company, right? So we are a neural search company. So our mission is to provide the cloud-native neural search solution powered by the state-of-the-art AI and deep learning. And we are a pretty young company. We just founded in this year in February. And but we are already close our seed round, right? So our valuation is at double-digit millions US dollars. And we have two offices. One is in Berlin, one is in Beijing. And yeah, you can follow our social channels such as LinkedIn, Twitter, website, GitHub, and so on. So I like to emphasize that we are hiring, right? We are hiring AI engineers, full stack engineers, product managers, open source evangelists from all over the world. So if you love open source, if you want to do open source as your full-time job, and of course if you love search and AI, then please send your resume to us, right? And we can work together on building Gina as the next neural search solution. Okay, so today's agenda, so I've already give a short introduction about who am I and what we are doing here. And so a good start would be like, let's talk about neural search, right? So what is so different about neural search, and how can we use neural search to do some things that we cannot do using traditional search, right? Yeah, I will also go through some hello world example and also tell you what is the best way to learn Gina as kind of like a framework. Right? At last, I will talk about our company's mission. Right, it's more beyond building an open source framework. It's about building an ecosystem around neural search. Okay, and eventually we will have some time for Q&A. So if you have any question during the session, right, so please write it down in the chat box, and I will go over it after this slides. Okay, so what is neural search? Right? So I believe the idea or the motivation of neural search is actually not very new, right? So it starts from the motivation of finding similar text in the large database, right? Finding semantic similar text. So for example, here I listed 3 definitions of microservice, right? So I just grabbed from Wiki, from other computer magazine, or from other tutorials, right? So this is from 3 different sources. And so the idea is actually you want to, let's say, given one paragraph of the definition of microservice, you want to find all the similar definition of microservices, right? While traditional search may not be very well in this case, may not serve very well in this case, because they are based on keyword. And usually in this scenario, you have to really understand the semantic behind that, right, in order to retrieve all possible definitions from the database, right? So this is a very, let's say, a very toy example, but of a real-world scenario. So you can imagine this kind of techniques can be used in chatbot, can be used in QA system, can be used in customer service, right? And so this is kind of like a semantic search. Okay, so what are the challenges here? Let's say we want to solve this kind of semantic text retrieval problem, right? So what are the challenges we must solve in order to build such system, right? And so here I list 4 challenges, 4 major challenges when we build a neural search system for text search. Right? So the first problem is how to quantize the semantics. How do you represent the semantics of a document, of a short tweet, of a paragraph, right? How do you represent that? Well, if I ask this question like 20 years ago, right, people have no idea how to represent this semantics properly, right? But nowadays, if I ask the same question again to you guys, and you know that you may answer, okay, then let's just use BERT, right? Let's just use one of those BERT algorithm models, right? So nowadays it's pretty clear you can use BERT or deep learning to represent a paragraph or document into a fixed length vector, right? So these mathematical vectors can be basically summarize all the semantic representation or semantic meanings of the original documents. And okay, so the first problem is solved, right? So the second problem is once we have this bunch of vectors, right? How do we store them efficiently, and how do we retrieve them efficiently? So some of you probably noticed that Facebook, like probably 5 or 6 years ago, released open source software called FAST, right? Facebook semantic search and index, right? And also Microsoft also released some kind of like this kind of vector database. There are also some existing open source vector database such as Annoy from Spotify, and also the Melvas from Zelis, right? And so they can be used to store the vectors in very efficient way. Okay, so it seems that we have a database to store this kind of thing, right? So the second problem is also checked. And now the problem comes to the how do we define the similarity, right? So once we have the vectors, once we can retrieve this vector from the database, now the problem becomes, okay, so why is this vector more similar to that vector compared to the other vector, right? And you can of course use very naive or straightforward metrics such as L2 distance, Euclidean distance, Hamming distance, and so But also you can use some very sophisticated models, such as you use deep learning to learn the metrics between two vectors, right? Or between two representations, just like we do in BiDAF in the machine reading comprehension, right? We learn the matrix rather than using simple cosine similarity. Right? Okay, so the last question is often ignored by a lot of practitioners, right? Is that does your model work on both super long or short document, right? It's a generality, right? So the solution of this generality is often you need to do some pre-processing. So for example, in this case, you have to segment your document into sentences, right? And for each sentence, you need to do the encoding, right? So this often requires some domain-specific knowledge for the pre-processing step. But it's super important, and often people, when they think about neural search, they just throw in a document and convert this document to one single vector, and that's actually not good enough if you do that in practice, right? Because semantic has kind of like there is a unit, there is a basic semantic unit where you have to optimize it, and this optimization actually is implemented in the pre-processing step. Okay, so let's see. Okay, so now we talk about the text, right? The text semantic text search, right? So what if we want to extend this kind of application into image and video, right? So what is changed and what is not, right? So basically, at least still here the four challenges here, right? So you can see that we basically solve the same problem, right? But rather than using BERT model to do the representation, right? We use, for example, some VGG, some CN, ResNet, this kind of CN-based computer vision model to do the representation, right? So that part is not changed at all, right? So you just replace the model by some computer vision model. Okay, so the last question that previously we talked about whether your model work on both long document and short tweet, right? But now we face more or less the same problem, right? But instead of working on the text, we're now talking about whether your model work on large or small images or long or short videos, right? So here you see the importance of pre-processing, right? So you need to segment the image or video into patches, right? And the size of each patch actually depends on, let's say, empirical experiments, right? Depends on your experience. So you need some domain knowledge to select the best adequate size for pre-processing, right? Okay, so combining all the three modalities, right? So we'll see that actually to solve neural search problem, there are a couple of issues or a couple of steps that one must go through, right? The encoding step to represent some document into real-world document to the vector, right? And the indexing step to store and retrieve the vector efficiently. The scoring step to compare two vectors in some kind of matrix. And also the pre-processing step, right? To select the correct size for vector representation. Okay, so if we put the neural search that we just talked about along with this traditional symbolic search, which could be based on elastic search, could be based on Lucene, could be based on Apache Solr, right? So what is the difference between the old one and the newer one, right? So we see there is actually not so much difference, right? So you all have this indexing step, which is often doing offline, right? And you also have this parsing step, which is in the online. So when user input some query, you need to do some parsing for this query and then represent that in the same space with the document that you've just indexed, right? So the difference is that in Elastic, we use analyzer. Right? We use analyzer to represent a query, to represent a document into some symbolic representation, and then the matching happens in that symbolic representation. While in the neural search system, we use deep neural network right, to do the parsing and to do the indexing, right? So we represent query and document into the, let's say, the latent space, right? The latent vector space. And then we do the matching there. So that's basically the difference, right? So we see, so if you want to know more about the traditional symbolic IR system, symbolic neural information retrieval, and also the neural information retrieval, please read this blog post, which I published like 2 years ago. Talk about how to do this, the symbolic one and neural search one, in an end-to-end way for product search. Okay, so the next difference between the next difference I want to highlight for neural search system is that for traditional machine learning system, you usually have two different runtime. So I call it runtime, but you can call it, let's say, running mode, right? For traditional machine learning systems, there is a train and there is test or inference, right? And for typical search system, there is an index runtime and search runtime. But for neural search system, because your model, your system is based on deep learning model, right? So there is a third runtime, and which is basically train, index, and search. Right? So this is another major difference between the neural search system and the traditional search system and the traditional machine learning system. Okay, so neural search seems to be a very promising, let's say, solution, right, to solve all this kind of cross-modality, multimodality problem. But what stops people from using that, right? So what is the problem? Why don't we see a lot of people using neural search in the production, right? So the problem is that the first scalability, right? So neural search is based on deep learning, but deep learning is very heavy, right? If you do that in production, your search system, the QPS of your search system is pretty low, right? The query per second is pretty low. And this is often doesn't meet the requirement of the production, right? Excuse me. Well, the second problem is the flexibility, right? So every time, I believe every morning you check out the Twitter, you check out the archive, you found some new models, right, pop up, and you want to integrate this new model into your system, right? So for example, if you look at BERT, right, after Google announces BERT or released the BERT, right, there are a lot of variants of BERT coming up, right? So you want to integrate them all, right? But actually, it is not that easy, right? So some BERT using they are based on different frameworks, they are implemented in different framework, or they require different dependency. So you cannot really, let's say, immediately incorporate those new models into your existing framework. So this is a flexibility problem. And the third problem is the sustainability, right? So a lot of deep learning models, they actually have a very heavy dependency, right? They depends on TensorFlow at 1.15, right? This kind of very concrete version restriction, right? And so how do you solve this heavy dependency, right? If your system is completely coupled with this kind of dependency. And often the deep learning system is multi-architecture, right? So some part of your system is probably running on CPU, the other part is probably running on GPU, right? So it's not really maintainable. And finally, the accuracy, right? A lot of people seeing deep learning as kind of like a black box, so they don't know how to tune that in a very accurate way, right? Okay, so those are the 4 challenges that people are facing when they want to build neural search into production, right? So Gina actually provides a solution, right? So that's why we do Gina, right? Because Gina provides the one-stop solution for solving all these problems. Gina is a cloud-native neural search solution powered by state-of-the-art AI and deep learning. So this is a slogan, right? So that we put on GitHub, right? So, but if I use simple word to explain what is Gina, right? So I often explain in three different, let's say, phrases. Right? So first, I want to say Gina is TensorFlow for search. Right? It's TensorFlow for search. So what is TensorFlow actually? So TensorFlow is just a symbol, so it doesn't represent the real TensorFlow, right? So it's just a symbol of all the general, very universal framework, deep learning framework, right? TensorFlow is very powerful, so you can use that to recognize cats from dogs, but meanwhile you can also use TensorFlow to play Go, right? So it is a universal framework, deep learning frameworks that you can do everything, right? Well, Gina is a framework that built on top of TensorFlow, right? It's on top of TensorFlow, which is dedicated, which is tailored to search applications, right? So this is what I mean TensorFlow for search. So the second is a design pattern, right? So basically, in the old days, in the classic search system, there is a certain design pattern, such as analyzing, tokenizing, this kind of thing, right? But when it comes to neural search, right, there is a new design pattern, and nobody has given this yet, right? So Gina actually provides not just a proof of concept. So we have iterated this kind of idea back in a couple of years, right? So we provide the design pattern, so you don't need to figure it out by yourself anymore. Right? The last is, of course, our company mission, right? So our company position is we see ourselves as the next Elastic, right? So this is how we see ourselves and what we are doing right now. Right. Okay, so yeah, so this graph basically explains where we position Gina, right? So you can see the AI development or the AI industry is like a inverse pyramid. Where at the very bottom you have the computing infrastructure. This includes the CPU, GPU, FPGA, cloud service, and so on. Right. So on top of that, you have the framework. You have TensorFlow, PyTorch, MXNet, Manspur, whatever. Right. And Gina is actually one layer above the framework, right? Above those deep learning frameworks. So we actually embrace all kinds of deep learning frameworks. And on top of that, we have end-to-end applications. This could be machine translation, image recognition, search, text generation, face wrapping, and data compression, and so on. Right. So Gina is a dedicated layer on top of the deep learning, on top of the universal deep learning framework, and it provides the infrastructure for search applications, right? For all kinds of search applications. So this is how we position Gina. Okay, yeah, so this is a list of what we can do right now with Gina. So you can use Gina for long text, short text, semantic search. You can use Gina for image to image search, video to video, audio to audio, or even any kind of document search, right? You can use it for multimodality search, cross-modality search, multifaceted search, and you can do index sharding, replicas, elastic, distributed workload, model containerization, Docker, all these things. Right? A lot of features that I listed here are already implemented in the current version, and some of them will be released in the next couple of weeks. And yeah, so basically, as you can see, we provide a one-stop solution, right, for all these kind of applications. Okay. So we as a company, actually, our goal is not to just implement one framework, one open source framework, right? So open source framework is play the core part of our company, right? So our core company product lines. But if you list all the product lines that we planned in our mind in the company landscape, right? We have Gina Core, which is basically the open source frameworks that you see on GitHub. On top of that, we have Gina Hub, which is basically marketplace, and it provides domain-specific solution, search-specific solution, right? So you can imagine the relationship between the core and the hub is like iOS and the App Store built on top of that, right? But we are not like a universal App Store. We only provide app for search, right? Whether it is image search, whether it's a dog search, cat search, The hub is actually driven by the community, right? It's contributed by the community. We also have a prototype of the hub on GitHub, so you can check it out. And we have Echoes. Echoes basically provide some enterprise features such as dashboard, auditing, log monitoring, alerts, this kind of thing. Right? And finally, on top of all of this thing, we provide the cloud service, but this is like a long-term goal. Okay. Highlights of Gina. So this is basically you can get all this bullet point from a GitHub. It's a universal search solution. It can search for any kind of modality, and it can even run on Raspberry Pi. So if you pip install Gina on Raspberry Pi, it will also work, and run Gina Hello World, it also works. And it is very high performance and state of the art. We actually spend a lot of time to polish the user experience, right, to help the developer on board. And we actually made the API very simple and very easy to use. And so this is when you use Gina to implement a neural search solution, you will realize that it's actually much simpler than you imagined, than you thought it was. Right? And also like Gina Hub is actually provides a very powerful extension and very simple integration to the Gina core. And you will see that in the Flow API. Okay, so I think a good start of getting to know Gina is actually to run this Hello World. Right? So if you right now you have Mac or Linux operating system and with Python 3.7 or above installs, then you can simply do pip install Gina and then Gina Hello World. Right? So it will run the end-to-end image search on your laptop. Right? So if you don't have like Python 3.7 or you don't want to install Python 3.7, but you have Docker installed, right? So you have Docker installed on your Mac, on your Linux. You just copy paste this kind of command line, one-liner in your terminal, and then you can run the Hello World. So here I will just run this thing because in the rehearsal I try to run this thing. And actually it eats a lot of resources, and turn out the video streaming becomes very laggy when I run this thing. But it's actually very understandable because Gina is actually, when you run Gina locally, right, it starts multiple processes and they start to communicate with each other, and that's actually like makes the video streaming very laggy, right? But so for example here, so I will just clear the terminal here. And you can run the Gina Hello World. I think you can just run Gina Hello World. Okay, so it will start to download the FetchMNIST dataset and do the indexing and so on. Right, I will stop here because otherwise it becomes very laggy. Right, so I will just stop here. Right, or you can also use so I will just clear the terminal here. Or you can also use like a Gina log profiling. You turn on the profiling and then turn on the log server. So once you do that, you actually will, you can go to our dashboard. You can go to our dashboard here, right? So you actually, So here you basically, you will see how so for example here, if I run this thing, and I probably shouldn't run this thing because then it becomes very laggy. Okay, let's terminate here. Okay. Okay, where is it? Okay, I will just terminate here because otherwise the computer is not usable anymore. But anyway, I have the screenshot, right, prepared, because this is always like the case when you show something, it becomes very buggy, and then you have to prepare some screenshot for the backup to cover the embarrassment of yourself, right? And okay, so anyway, so what does it do, right? What just happened if you run the Jina Hello World, right? It's basically showcase an end-to-end neural search system with index and search two procedures, right, in one line. Right? So first, it downloads the FetchMNES dataset, including the training part and test set, and also the 60,000. So it then through the 60,000 training images for indexing, and then it randomly sample 50 queries from the test set, and then from the top 50 visually most similar images and write to an HTML, right? And so this is what happened, right? So as you can see the result. Okay, so Hello World is very simple, right? So you usually expect that it is very simple, right? But it's actually, so if you look at the implementation behind that, it is also very straightforward, right? So we have a Python API which basically loads, let's say, a workflow from a YAML file, right? YAML is like a JSON file, right? So it's like some kind of a schema that some domain-specific language, right? Defining domain-specific language. Yeah. So YAML file is look like that. So it basically defines a workflow, right? And so we have parts, we have this kind of different components here. So each component can be, so we call it part here, but it's actually, you can imagine it's like each part is like a microservice, right? And so if you say, okay, so I never learned YAML, I'm a JSON guy, right? So I'm a JSON guy, I don't like YAML, right? So that's no problem. So you can design your flow, right, in the dashboard, right? So by just drag and drop there, and and then you just copy the generated YAML to some file and then load it. So that's it, right? So it is actually, we provide different ways for you to design the flow. That includes using the Python API, using the YAML file, or using the dashboard, and we will see that later. Okay. Yeah, so all these logs, so when we run this thing, right, so yeah, so let's just scroll it up a little bit. So when we run this thing, you see a lot of like this triangle, and it seems like a message is propagating. It is, right? It is a message propagating over different microservices, over different paths, right? So you can see that, oops, where is it? Okay. So you can see each part here in the flow actually corresponds to the to the line, to each log here, log record here, right? So and yeah, so that's basically how Jina works, right? It propagates the request into different microservices, so it's actually parallel in nature. Okay, so that's a good start, right? So you see the log is scrolling, you have very intuitive idea, the first impression of how Jina works. You'll understand, okay, Jina is probably like propagating something in message over all the microservices, and Jina is kind of like, yeah, you can deploy all these microservices here and there on different machines. So you get the first idea, right? But in order to understand how Jina really works, so I should suggest everybody read Jina 101, this key concept in Jina, right? So it's actually explained everything in a very, let's say, cartoonish way, right? So you can just simply type Jina 101, right? And then you go to this page, right? So you see it actually explained from very low level to from the very low level, from the document and chunk to YAML config and the executor, a family of executors. So you see these four guys, right? So these 4 gear guys, right? This actually corresponds to the you remember the 4 different four important steps that we do when we do the neural search, right? Encoding, preprocessing, and storing and indexing, right? So those 4 gears actually corresponds to that, right? But actually the families are not restricted to those 4 gears, right? So we can at any time adding more gears, adding more family members to this executor family, right? And we have driver, we have P, part, flow, and eventually we have this kind of like a big family here. Right? Okay, so that's good because it actually, so for those who don't know much about microservice, because I know some probably data scientists, they never learn like a microservice in a very, let's say, in a very formal way, right? So that's fine because you just read Jina 101 and then you get the idea, right? Okay, so what are those characters if you put that into the code, right? So here you can see that this is actually the source code behind Gina Hello World, right? So from the left column, from the leftmost column, we have the executor, right? We have all this like a crafter, segmenter, encoder, all this very, let's say, algorithmic unit, which is basically like written in Python or NumPy, right? And but those executor they cannot talk to each other, right? So because they are actually isolated in the microservice, right? So you cannot just talk to each other like you're talking the Python function, right? So in order to do that, you actually have to grant some kind of communication ability, network communication ability, by using the driver. So this driver basically defines how this executor talks to each other under some kind of request, right? So for example, under the index request, okay, so how should you talk to each other, right? Under the search request, how should you talk to each other, right? And this talking schema actually is defined with YAML config, right? And then one layer on top of that, we can wrap all the driver executor YAML into a P, right? And you can also, let's say you want to start multiple Ps, and you just wrap all the Ps into a pod, right? And eventually you put everything in a flow, right? So the flow actually represents a high-level task, such as indexing, searching, training, this kind of thing, right? And yeah, so that's actually from the micro level to the macro level, from the left side to the rightmost side. Yeah, I think there is an animation, yeah, from the micro level executor to the driver, and then driver with YAML, they wrapped into a P, and a P, if you want to scale it up, you want to set replicas, you want to set shards, and so they are wrapped into a single pod. And then you connect the pod together with a flow API, and this finally becomes your high-level task in the flow. So this is how the logic evolves, right? Okay, so now let's talk about the flow API, right? The flow API is probably the first thing that you notice when you look at all the examples, all the tutorials in our GitHub, on our GitHub repo, right? So flow API is actually the interface that we provide. It's one of the interfaces that we provide for developers, right? So you can use that to, it's like a translate layer, right? So you can translate the YAML file, the Python file, or even the dashboards, the interactive dashboard, into something that you want to, some kind of backend that you want to run, right? So if you use Flow API locally, right, then basically it runs as a multi-process or multi-threading, right? You can also use Flow API to run, to start Kubernetes and the Docker Swarm. So that's also possible. So Flow API, strictly speaking, is like a context manager for managing all the P paths and all the context of all these P paths. So you don't have to worry about who connects to who and what is a port number and how should they communicate with each other, right? And these are all taken care about by the Flow API. And Kubernetes support and Docker Swarm support and other orchestration layer support, this is still under development. But at the end of the day, so you can use Flow API to generate the YAML config or JSON config that you need to deploy it on the cloud. Okay, so here I list some very usage, some very simple usage of Flow API. So as you can see here, adding a pod into the flow is actually very simple. So you just use add, and then you give some attributes and also the YAML file, YAML path, right? And then you can also say, so this is very interesting. I always like it. I always like this feature because I think this is how we, one of the highlights in Flow API. So basically you can run one of the part, right? Not all the parts, one of the parts remotely, right? And you can also run one of the parts remotely inside a Docker container by specifying the image of this part, right? So once you specify the host and the image, then this part is actually, is like wrapped in the box and then put it on the other side of the earth, right? Yeah, so this is a very powerful feature, and then you can of course build parallel steps by using the keyword needs and join, right? So you can branch the steps and do it in parallel, and then wait until all the steps finish. So this is a Python API, right? For some reason, people, let's say you do this in production, right? You can now change the source code so frequently, right? So that's why you separate the code itself from the, you separate the structure of the flow from the code itself, right? So that's why you write a independent YAML file, right? So that's no problem. So you can use Flow to load this YAML file into memory and run this flow. To feed data into a flow is very simple. You just use with this kind of like a context manager. You open this context and do the F.search, and that's it, right? So this is, and you give the input function to tell the flow, okay, so you should grab the input from this function, and this function is probably some generator, right? And okay, then you should write your output with this kind of callback function, right? So in this case, it's as simple as print, right? So that means actually every time you receive a request, every time a requester make a round trip, right, back and forth, then you print it, right? So this is as simple as that. Okay, here I list all the examples that we have right now for advanced PPaaS API and Flow API usage, right? So you can see we have feature extraction. This is some feature that I was always asked by the community when I was doing the bird as service, right? And people often ask me, okay, Han, can you do X as service, right? Can you do Albert as service? Can you do whatever BO bird as service? Actually, in this case, if you use Gina, that's actually like a work out of the box. You just give a different Docker image, and that's it. And so you use the same workflow, you use the same pipeline, and then you can extract the feature, right? So in this case, we give an example. We use Hugging Face Transformer to extract the feature, well, and scale it in parallel. Right? So it's pretty simple. And we have image search. This is not so big deal, right? So searching flowers, searching similar flowers. We have QA search. This is I believe this is a source pack script, and so you can type in a script and then it will look for similar script. Right? We also have a video search, right? So this is based on Tumblr GIF dataset, right? So you basically can throw in a GIF image and go like found all the related videos, right? And here, back to the Hello World example, we can also split the Hello World into client and server architecture, right? So you deploy the server on the remotely, and then you use local client to send data to the server, right? So this is so you can find out the examples here, right? It's also very simple, very intuitive. So all these examples are available on GitHub, so you can use the shortcut learn.jina.ai to get all the examples. Okay, so now let's summarize a little bit. So we have seen Gina can do this and that, can do a lot of things, right? So when people come to the Gina GitHub repository, right, they first think that Gina is probably some like a very small toolkit, like a bird as service, right? So it's, and then once they realize that Gina is actually it's very ambitious. It's actually doing a lot of things, and it's trying to become the cloud native framework for neural search, right? And they become scared, right? They don't know how to start, right? They don't know where to how to learn this thing, right? So here I summarize the best way to learn Jina for beginners, right? So first, as I said, you have to run the Jina hello world, right? We spend quite some time to make it very. There is actually no dependency for Jina hello world. You just pip install Jina and then run Jina hello world. You don't need any TensorFlow or specific version or PyTorch or whatever, right? You don't need some database, MySQL, NoSQL, whatever. Right? You just run Jina hello world. Everything can be run out of the box. And if you don't have Python 3.7, right, then you use Docker, right? So this is also doable, right? And then after you run the Jina hello world, you read Jina 101, right? So this is like a must. You must read this thing, right, to understand the key concept, to understand the P path, to understand what is the driver, executor, this kind of terms, right? And then once you get these cartoon characters, once you get to know these cartoon characters, you can read the first two tutorials. One is the Flow API, so that you know how the examples work, right? How the examples are written. And I/O functions. I/O functions are also, of course, very important because you have to know how to feed and retrieve data from and to the flow, right? To and from the flow. And then once these steps are done, you can really dig into the hello world example and look at the other more advanced search applications such as NLP, this poem search, script search, image search, flower search, video search, and so on. Right? And of course, if you anytime encounter any problem, you can read the docs. We actually build the docs in a very, let's say, we actually spend some kind of like a graphic design effort on the docs because we know that developers spend a lot of time on docs reading. So we want to make sure that their experience are actually more enjoyable. Okay, so after all these steps, right, it's now really like you can build your own search system with Jina. Yeah, try that. Try to build your next search system with Jina. Speaking about the learning experience, we really care about the onboarding experience for new developers. Right? So that's why we actually define different milestones for developers, and we actually optimize the learning experience for different level of developers. Right? So we have the one-on-one cartoonish storybook, and we have the very comprehensive, and we will still adding more examples to the tutorial list, and we also have very nicely written, well, at least it looks very beautiful, right? Document here, and we will also launch our tech blog like in the next month. The tech blog will also be community driven, so we will write something, and we also encourage community to share their learning experience about Jina, and we can publish it together. Apart from that, so if you ever encounter any issues when using Jina, please submit an issue on our GitHub repository, or if you prefer more like an interactive chit chat style, you can use our Slack channel. So we already have some members there, and so we have like a daily discussion about so what is Jina, and how to do that, how to do this, what is wrong with this bug, this kind of thing, right? Okay, so that's basically concludes the AI, the Jina as a project. So now let's talk about the Jina AI as an open source company, right? So the first thing I always I was often asked by some people is that, okay, the Jina is great, Jina is ambitious, so why don't you work Jina at X? And X is some kind of like some tech giant. And my answer to that is that we actually care more about neural search. We care more about the community. We care more about the open source. And that's why I'm stepping out from the tech giant and doing this as a startup, and raising money to do that as a startup. And we actually, so all of our co-founders that we actually share a very strong belief that open source AI infrastructure is the future, right? And we believe that we want to build this thing with the community, right? And there are a couple of things that we want to change, and we will change that. So this is our very strong belief. And so our company culture actually encourage people to change things if they don't like that, right? And yeah, so that's basically the answer. Another. So some people may think of that. Okay, so if you work that in the tech giants, right? So you probably get more resources to, let's say, PR for branding and so on, right? But that counts as a hobby for the tech giants, all right? But this is something more for us. So this is a major difference because we care more. Because we care more, we can pay more details, pay more attention to optimize for the community to make this project more sustainable and open source. And this is the thing. This is the reason and motivation what drives us to do this as a company. Right? And we also have our own understanding about the company, about open source, right? A lot of people think that, okay, so open source is probably like you open source your source code on GitHub, right? And then you collect the stars, right? And actually, that's the easy part. The more difficult part is the open governance, right? How do you make your project sustainable over long term? How do you provide long-term support, right? And fortunately, we are a venture-backed team, so we have enough funding to give this Gina very long-term support, and we will build a lot of synergy with the community, and to have a more open governance model here. Right. So here specifically, we will make our projects very sustainable and also community-driven. We will build synergy with other open source software. So if you look at our Gina code, we actually have already incorporated many interfaces such as TensorFlow, PyTorch, this kind of thing, and also Hugging Face Transformer, and also Farm from DeepSet, and Fast from Facebook, this one, right? So we love to do the synergy with other open source software. And we are also looking for partnership to build an open governance model, such as a technical steering committee around Gina, so we can discuss the challenges and the blocker in the neural search, and then we can solve it and push the whole community forward together. Right? Okay, so that being said, if you are interested in any of the jobs that we provide, so we actually, right now, as I said, we have AI engineers in full-time and AI product manager, open source evangelist, and also the full stack engineers. So if you're looking for any of the full-time job doing open source, especially AI in search, if you believe neural search, then please submit your resume and follow the instruction on the website. And we are looking forward to have you on board. And so that's basically it. That's basically today's session. And I don't know what time is it. Okay, so it's about time. And we will. There are a couple of things I didn't cover in this episode, right? For example, how to do Gina in the remote setting. This is already doable, but given the time constraint, I cannot show you. But you can check out the GitHub repository and find out the thing, right? And also, like, how do you extend Gina with your own deep learning AI models? This already, you can check out the Gina Hub. And so we actually have a pretty detailed README on Gina Hub. You can check it out and find out how to extend your model, how to extend your deep learning model with Gina. Okay, so now comes to the Q&A session, and I will switch back to